Dear students, we are going to the chapter-wise concept, that is matrices and determinants. Now types of matrices. Now we are going to another type, that is rectangular matrices. Rectangular matrix. Rectangular matrix. If a matrix is said to be a rectangular matrix, then which contains the number of rows not equal to number of columns. If a matrix is said to be a rectangular matrix, then which contains number of rows not equal to number of columns. Number of rows not equal to number of columns. Number of rows not equal to number of columns. Now we are going to compact form of the rectangular matrix. Compact form. So compact form is very important. This is the most useful formula, especially for objective. Okay, that's why compact formula. Compact form. If a matrix, capital Aij, where m by n. So this is the representation of the compact form. This represents the representation of the matrix. So this is matrix representation of order m by n, which contains m rows and n columns. Is said to be a rectangular matrix, then m not equal to n. Since m represents rows, number of rows, n represents number of columns. That's now examples. Example 1. A is equal to 5, 6, 7, 9. 3, 6, 4, 5. So which contains 2 rows and 4 columns. It is a 2 by 4 matrix. So it is the rectangular matrix of order 2 by 4. Is the rectangular matrix of order 2 by 4. Since which contains 2 rows and 4 columns. That's why number of rows not equal to number of columns. One more example. Example 2, that is B taken as a matrix, then it represents 0, 7, 5, 9, minus 3, 6. So which contains 3 rows and 2 columns. 3 rows, 3 by 2 matrix. That's why this is another example for the rectangular matrix. Since number of rows 3, number of columns 2. That's why number of rows not equal to number of columns. That's why it is called rectangular matrix. That's why these matrices in the shape of rectangle. Since rectangle, it may be length is greater than breadth or breadth is greater than length. That's why here according to that position rectangular matrix. So number of rows not equal to number of columns, then the matrix is called rectangular matrix. That's all. Now we are going to another form. So these two are called rectangular matrices. Now we are going to square matrix. Another type of matrix, that is square matrix. Square matrix. Square matrix. If a matrix is said to be a square matrix, then the number of rows is equal to the number of columns. That means which contains same rows and columns. So, if the definition for square matrix, if a matrix is said to be a square matrix, if a matrix is said to be a square matrix, then which contains number of rows is equal to number of columns. Number of rows is equal to number of columns. Number of rows is equal to number of columns. Now compact form for this one. Compact form. That is, if a matrix capital A is equal to Aij, capital A is equal to Aij, where M by N. That means we have to take the matrix, representation of the matrix is Aij, where Aij is nothing but the element in the matrix which belongs to ith row and jth column. The elements in the matrix which belongs to ith row and jth column is said to be a square matrix. Is said to be a square matrix. Is said to be a square matrix. Is said to be a square matrix, then M is equal to N. Then M is equal to N. That means here M represents number of rows, N represents number of columns. That's why number of rows is equal to number of columns. Then this matrix represents square matrix. Now examples. Example 1. Examples. Here we have to take capital A. Here it is 1, 2, 5, 7, 3, 6, 9, 4, minus 8, 3. So this is which contains 3 rows and 3 columns. That's why which contains 3 rows and 3 columns. Number of rows is equal to number of columns. That's why this is the square matrix of order 3. So 3 by 3 read as order 3. Order of 3 by 3 is nothing but order of the matrix 3. Order of the matrix 3 by 3 is called order of the matrix 3. Simply order 3. If the number of rows is equal to number of columns, then the order of the matrix is, that means if the number of rows is equal to number of columns is equal to n, then the order of matrix is n. That's why. So one more example, that is example 2. That is taken as B. Here it is 0, 0, 1. So this is which contains 2 rows and 2 columns. That's why it is the square matrix of order 2. It is the square matrix of order 2. Like that, we have to take the example 3. That is taken as, suppose X. X is the matrix such that here we have to take A11, A12, A13, A14. Here it is A21, A22, A23, A24. Here it is A31, A33, A32, A33, A34. Here it is A41, A42, A43, A44. Observe, which contains 4 rows and 4 columns. It is the 4 by 4 matrix. So that is the square matrix of order 4. So that is the square matrix of order 4. That's why the entire matrix represents a capital letter. The elements in the matrix represents small letters. Clear? This is the definition for the square matrix and the examples. Okay. That's why order of this square matrix is nothing but number of rows or number of columns. Order of the square matrix is nothing but number of rows or number of columns. Since number of rows is equal to number of columns, that's why suppose a matrix of order n by n, then simply it is called square matrix of order n. That's all. That's why this is the square matrix of order 3. This is the square matrix of order 2. This is the square matrix of order 4. That's all. Now we are going to one more definition, that is null matrix. Null matrix. Null matrix. So the definition for null matrix or zero matrix. Null matrix or zero matrix. Null matrix or zero matrix. Sometimes it is called zero matrix. Null matrix or zero matrix. If a matrix is said to be a null matrix or zero matrix, each element or each entry in the matrix is 0. That means suppose we have to take a matrix in the null matrix. Each entry, that means observe, these elements are also called entries. These elements are also called entries. What are the entries here? 0, 7, 5, 9, minus 3, 6. That's why elements involved in the matrix are called entries. That's why each entry or each element is 0, then the matrix is called null matrix. It may be a rectangular matrix or a square matrix or whatever it may be. Each and every element in the matrix is 0, then the entire matrix is called null matrix. That's why null matrix. If a matrix is said to be, definition for this one, if a matrix is said to be, if a matrix is said to be, if a matrix is said to be a null matrix, if a matrix is said to be a null matrix, if a matrix is said to be a null matrix or zero matrix, null matrix or zero matrix, zero matrix. If a matrix is said to be a null matrix or zero matrix, then each element or in bracket each entry or each element or each entry is 0, in the matrix is 0, which contains, if a matrix is said to be a null matrix or zero matrix, then each element, then you have to write here, then each element or each entry is 0, in the matrix, 0 in the matrix, 0 in the matrix. Are you clear? That's why now compact form for this one, compact form for this one, compact form. Compact form. If a matrix, capital A is equal to Aij, if a matrix capital A is equal to Aij, where M by N is said to be a null matrix, is said to be a null matrix, is said to be a null matrix, is said to be a null matrix or zero matrix, is said to be a null matrix or zero matrix, then what is the element in the compact form? Aij. That means Aij must be 0 for all I comma 0. Aij is 0 for all I comma 0 matrix. Then Aij is equal to 0 for all I comma j. Aij is 0 for all I comma 0. Okay, that's why this null matrix also represented by O. This null matrix also denoted by O. Null matrix also denoted by O or O m by n. That means O m by n is nothing but null matrix of order m by n. Null matrix of order m by n. That's all. Now examples. Example 1. Example 1. Here O 3 by 4 matrix. O 3 by 4 matrix, which contains, O 3 by 4 means, which contains 3 rows and 4 columns. 3 rows, 0, 0, 0, 0, 1 row, and 4 columns, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That's all. So this is 3 by 4 matrix. This is the null matrix of order 3 by 4. This is the null matrix of order 3 by 4. And another example. Example 2. O 2 by 3. O 2 by 3. That means which contains 2 rows and 3 columns. 0, 0, 0, 0, 0, 0. So which contains 2 rows and 3 columns. And another example. We have to take another example. That is O 3 by 3, which contains 3 rows and 3 columns. 0, 0, 0, 0, 0, 0, 0, 0, 0. That's why this is 3 by 3 matrix. That's why these are remaining types of matrices. Rectangular matrix. If a square matrix is said to be a rectangular matrix, then the number of rows not equal to number of columns. Then the number of rows not equal to number of columns. Then the number of rows not equal to number of columns. Okay. Now, square matrix. If a matrix is said to be a square matrix, then the number of rows is equal to number of columns. Number of rows is equal to number of columns. Null matrix. Each and every element in the matrix or each and every entry in the matrix must be 0. Then the matrix is called null matrix. So, compact forms are very, very important. Actually, matrix representation, matrix denoted by capital letter, elements in the matrix denoted by small letters, maybe numerical values. That's why here capital A is equal to Aij m by n. That is the formation of, that means compact formation of the matrix representation. So, which contains m rows and n columns. If it is rectangular matrix, then the number of rows not equal to number of columns. That's why m not equal to n. For this one, square matrix. Again take the same compact form, capital A is equal to Aij m by n. If it is square matrix, then the number of rows is equal to number of columns, that is m is equal to n. And null matrix, the compact form is capital A is equal to Aij m by n. That is the common form, compact form of the matrix. So matrix representation, that is capital A is equal to Aij where m by n. M rows and n columns. But according to the definition of the null matrix, each and every element involving in the matrix is 0. That's why this Aij represents the element. Aij is nothing but the element which belongs to ith row and jth column. That's why Aij is 0. Simply Aij is 0 for all I comma j. That means respect to row and column. With respect to the row and column. That's all. So these are the examples. Here rectangular matrix. This is 5, 6, 7, 9, 3, 6, 4, 5. 2 rows and 4 columns. This is the rectangular matrix of order 2 by 4. This is also called horizontal matrix. This is also called horizontal matrix. In the horizontal matrix, m less than n. And this is m is greater than n. That's why which contains 3 rows and 2 columns. That's why here m not equal to n as well as m is greater than n. That's why this is the rectangular matrix as well as this is called vertical matrix. Since in the vertical matrix m less than n, m greater than n.